So the first one says if you combine all of your rational with all of your irrational, you get real numbers. Is that true or false?
True.
That is true. 12 says that if you intersect all of rational with irrational, the ones that cross over are none, empty set. Is that true? Yeah, that's actually true. If you intersect those two, there are no numbers that are both rational and irrational, right? There's none that cross over those, all right? Let's look at 13. This is saying that rational numbers are a subset of integers. So if you just look across the page, you will see that little Venn diagram there. Are rational numbers a subset of integers? It's actually the other way around. Remember, if it's inside, that means it's a subset. You'll notice that the rational is outside of the integers. So integers would be a subset of the rational, but rational is not a subset of the integers. It doesn't go the other way. So this one is false. All right. What about 14? Natural numbers then are a subset of your integers. Yes, the natural numbers are inside the integer ring. They fall within the integers. So this is true. Whole numbers are not a subset of your integers. True or false? False. They are a subset. They fall within that ring. Integers are not a subset of irrational. That is true. Remember, irrational is this own little monster over here all by itself. There's nothing inside of it, right? It's all its own little compartment. So that is true. That is not a subset of the irrational. The empty set is a subset of real numbers. It is a set. Are they using the right notation? Set? Yes.
Channel 2.
Remember, empty set's really a subset of all sets, right? So this guy is true. All right. Now, if they had said element, they would have used the wrong notation, right? Because that represents an entire set of numbers. Granted, an empty set, but it represents an entire set. Natural numbers is an element of real numbers. Why is this false? It's not an element. Natural numbers is a set. They use the wrong notation here. If they had said 3 is an element of real numbers, yes, 3 is an element. But anytime they use a set, whether it's by that capital letter or with set notation, they then have to use the subset or not a subset notation. They cannot use the element. So this guy right here would actually be false. 0 is an element of the empty set. That's false. Because 0 is an actual number, right? 0 is an element of which set of numbers? The lowest one is whole, right above natural, right? And then it's integer, rational, and real, right? So this is not true. The empty set means there's nothing in it. 0 is an actual number. It represents something, okay? So very often, especially in your math class, but in life itself, you are going to see numbers represented different ways. One of the ways that you see it is a number line, but number lines look different sometimes. The standard number line that you're used to is this first one up here, where you just have a line, you set a marker that equals 0, and then on the right-hand side you have positive, on the left-hand side you have negative. That's one way to look at numbers. Another way that you're probably familiar with, if you have an outdoor thermometer, they often look like this, right? And they have temperatures. You also notice here we have a 0. This is Fahrenheit, so we have a 0 here. Fahrenheit's on the left. So these represent negative numbers down here, and these represent positive numbers up here. Another way you're going to see this is like sea level. You're going to hear the term above sea level, below sea level. That's a type of number line, even though you don't visually see it. And so these are just representative of numbers. And it's just showing on this little map of the numbers where this particular number belongs. So when you do a number line, you have the origin. The origin is your starting point, your 0, what marks the positive side to the negative side. It's the guy that falls in between. And so when you draw a number line, you usually have to indicate that 0 is on there. And then you're going to have your little dashes that represent your numbers. Then you have what's called coordinates. We'll get to coordinates on a coordinate plane, which is like x, y. But these are coordinates on just a linear number line, right? And these coordinates are represented by a capital letter. All right, and so we have a capital letter that tells me this is the location. Think of it as an address. All right, so the address of A would be -3, the address of B would be -5, and so on and so forth. So if I said, what's the coordinate for C, you would tell me 2. All right, and so each of these is represented by a capital letter, and it is placed somewhere on the number line. So hopefully we've all done this. So the first thing we're going to do is we are going to go through and create a number line. All right. To create a number line, it gives you these basic instructions. Draw the line, choose a point as the origin and label it. Mark it with segments of equal length. Number the marks consistently with the numbers to be graphed and place a point at the indicated number on the number line. So they've given us some integers, 3 and -2, and then they have given us some rational numbers, 1.5 and -3 and 2/3. So typically on a number line, you're going to have your integers, right? And then when you place the other ones that fall in between it, you're going to just make sure it's between the right two numbers. Like, I'm not going to get a ruler out and be like, well, you weren't exactly 2/3 away, right? I'm not going to be that picky. As long as you're between -3 and -4, then I know you know where it belongs, right? And so when you have a number line, you're going to first draw your number line. That's important. And then you are going to draw your marks on it. So you want to draw a line. You want to have arrows on it. I know this seems specific, but remember, integers are infinite. They go infinitely to the positive and infinitely to the negative, right? And so that's what that arrow indicates. And then you want to mark where your 0 is. And of course, we have our dashes. And again, I'm not going to measure that you put them exactly the same distance. You do want to label these guys, preferably in numeric order. That's good. All right, and then when you put your numbers on here, you want to just put the dot and the letter that it represents. So I want to graph my first one, A. I'm going to go to +3, put a dot, and then I am going to put the letter A above it. You're going to need to do this when we graph on the coordinate XY as well, all right? I mean, I know where it is, but I need to know that you know where it is, right? And so you're telling me A is there. So we're going to do this for all of these. 1.5, again, that's going to fall in between what two numbers?
1 and 2.
1 and 2, and so I'm going to put a dot there. -3 and 2/3, where is that going to fall?
-3 and -4.
Yeah, in between these guys. Remember, with negatives, you go backwards almost. -3 and 3/3, 2/3, right? Questions on that? If you have something like this, you're going to do it exactly the same. You just have to keep in mind that it is up and down. So you'll see that they put the -0.5. There's the X. 1 1/4. That was up here. And -1.4 down here. Also pay attention to what your scale is when you're doing a number line. So if they give you a number line and it's already labeled, pay attention to your scale. For example, 1 1/4. These are not representative of 1. They're representative of 1/10, right? And so you need to keep that in mind when you're graphing something like that, what your lines actually represent. But it doesn't matter if it's horizontal or vertical. You're simply placing the coordinate and putting the letter above it that it represents. All right? When I graph these, and I didn't give myself enough room, so you're going to be way off. I'm going to make these 10s for this first one. We'll say that's 10, 20, 30, just because I didn't give myself enough room for large numbers. All right, so assuming those are by 10, if I went to -24, it should have been in between 20 and 30, -20 and 30 right here, and 32 would be in between +30 and +40 right there. All right, so when I say scale, I wouldn't have wanted you to do 30 dashes. Make it in groups of 10. Be logical when you draw your number line, right? Now for the next one, I would have drawn this in at most single integers, right? And so for this next one, I would have left it at something like that. 1 3/8, that's going to be about right here. And then -3/4, that's going to be about right here. And again, you could even draw that scale smaller. You could have drawn it in half marks. 1/2 to, 1/2 1, 1 1/2 2, etc. Oh yeah, I should have drawn it further. Sorry. That goes over here. I threw myself when I did my positives and 10s. All right. State the coordinate. The coordinate of U. What do they want? They want me to tell them where it's located. 20. All right. Questions on those? So opposite numbers are numbers that are the same distance from 0, but opposite sides of 0. So 3 is the same distance from 0 as -3, but they're on opposite sides. That's what opposite means. You basically just change the sign. If it's positive, negative, if it's negative, positive. So fairly simple. If A is 12 and they want the opposite, I'm going to write -12. B is -37, I'm going to write +37. It doesn't matter if it's decimal. You simply just make the sign opposite. Doesn't matter if it's a fraction. You just make the sign opposite, okay? So when you hear the term opposite, they literally mean the opposite sign on the opposite side of the number line. A mirror image, pretty much, is what opposite means. And so when you take that information and then you start talking about absolute value then represents the distance away. So that's why opposites will have the same absolute value. They are the same distance away. By definition, that's what opposite meant. And absolute value means how far away are you? And so the absolute value is always positive because we're talking about distance, right? Okay? So if I were to say that I am 6 feet away from Cole, I would not say Cole is -6 feet away from me. That does not make sense. Distance is always positive, okay? Negative means direction, okay? So like if I'm playing football and I gain 12 yards, they're going to say +12. They're going to say -3 yards. That doesn't mean they actually went -3 yards. They went 3 yards. They just went in the wrong direction, okay? So positive and negative represent direction, but distance is always positive, okay? So if I'm talking about direction, then I need to give a direction. I need to tell you which way I'm moving. But if I'm just talking about distance, absolute value, then it's always positive. And so if you look at the next group, it says the absolute value of a number, and they have the notation. It looks like just 2 lines on either side of the number, is the number of units or the distance between that number and 0. So this is why your absolute value is always positive. And you can see they have 4 and -3. Well, for 4, if I start here at 0, I move 4 units to get to 4. Well, -3, if I start at 0, I move 3 units to get to -3. It is a distance. So my answer for absolute value should always be a positive number because I'm strictly talking about a distance. All right? So then we get into equations using absolute value. When you have equations using absolute value, you want to do the absolute value, but if there's something going on within it, you do what is within it. You think of it as a grouping. So when you think back to order of operations, you do your grouping first. Well, absolute value is a way to group, all right? And so for this first one, I have 74 absolute value minus -24 absolute value. So in this case, I'm actually going to do the absolute value first. I'm going to say the absolute value of this, that is just positive 74, minus the absolute value of this, that is 24. And then I'm going to subtract 74 minus 24, and that's going to give me 50, right? But for this next one, it's grouping this subtraction problem. So for this next guy, I'm actually going to do this piece first, and then I'm going to apply the absolute value. So I'm going to say 82 minus 31, that is 51. And I am still within my absolute value. Now, it doesn't really matter on this one because it's positive. But at this point, then I'm going to take that absolute value. And I'm going to say, okay, my answer then is 51. Some people have a tendency to just change the sign with absolute value. That's not what it does. It just is a distance, so it's always 0. I mean, it's always positive, all right? Because we're doing a distance from 0. So when you put 2 points on a number line, what you've actually done is you have created a segment. A line itself is infinite. A line goes on infinitely in 2 directions, all right? But a segment has endpoints. And so when you put 2 points on a number line, what you've created is a line segment. You've created something that then stops, okay? And so one of the things that you can do is figure out how long the segment is, all right? So once again, because we're talking about length, you'll notice that it has an absolute value when it gives the formula for this. And it actually doesn't matter which way you subtract because it's absolute value. So the example they gave us is that A is located at 4 and B is located at 10. Now the formula says do B minus A, but once again, it might not always be labeled that. And it doesn't matter which order you subtract in because the absolute value is going to supersede that order. What do I mean by that? Well, if I want to find the length of this line segment that I created, I could say, well, the length is going to be 4 minus 10, absolute value. Or I could have written it this way, 10 minus 4. Why? Well, because I'm going to do what's inside first. 4 minus 10 is negative 6. 10 minus 4 is positive 6. What do we know about the absolute value of negative 6 and the absolute value of positive 6? They're both 6. So my answer here is 6. So really when you're finding the length of a line segment, you're just subtracting the two numbers and taking the absolute value. That is the length, okay? So it really doesn't matter what order you do that in. As long as you apply the absolute value, you're going to get the correct length, all right? So that's the first thing you have to know is how do I find the length of a segment? Take the endpoints, subtract them, and then take the absolute value. The next thing you're often asked is where's the middle of this particular line segment? Where is the middle of the line segment? And that formula is on the page, next page, page 10. For the middle of the segment, you actually add your endpoints and you divide by 2. You can think of it as averaging, okay? So when you average two numbers, you add them up and you divide by how many numbers you had, all right? Same thing is true here. So again, it doesn't matter what order you do this in because you are adding. Now, you'll notice there is no absolute value around this. So your midpoint can be a negative number because you are just saying where on this line is the exact middle of my line segment, okay? And so to do this, you're just going to take the two numbers and you're going to add them, which means you could have a decimal, right? Because you could have two numbers that don't add up to an even number. For this one, my first endpoint is at 4. My second endpoint is at 10. So I would just say 4 plus 10, and I would take that and divide by 2. Remember, when you're doing this, you just automatically assume grouping there. Numerator and denominator groups. So I would say 4 plus 10, that is 14, divided by 2. My exact midpoint then is right here at the 0.7. All right? So when you're finding distance, you subtract and take the absolute value. When you're finding midpoint, you add and divide by 2. All right, so a couple of them.